Starting stream. There we go. Second time's a charm today. Okay. Let's get back to development. Day 3. This is day 2 of Unreal. I think it was day 2, right? No, it was day 3. I'm going insane here. Okay. So let's see what we got here. We've got right, we got one play. There we go. We got this, works, this. We're gonna have to do animations for this because it feels funny, but that's just because of like him moving this way. There we go. Jump works. You can only zoom in so far. Zoom out has a max distance. And then we come over to the log here. We can click to select things. Oh, you can't click this character, eh? Like, interesting. So, wait, does that mean that this has a different collision on it? Where's the collision for this? There's a camera. I don't care about the camera. Collision. Oh, camera. No, this is the camera collision. Don't care about the leg. Physical, here we go. I think this is it. Simulate update components. Huh. Maybe it's around here somewhere here. Can character step up on collision presets? Maybe this? Pawn object is used for character mesh. All other channels will be set to default. So update. Wait, what did I have as the option for this collision here? Sup, Goofy King? Let's see here. I think it's down here. Target object. Here we go. Hit result, right? So this is where we store it, and then here we get it. But here we've got ECC and visibility, which I guess would be something else. ECC physics body, maybe? Or no, ECC pawn, maybe? Let's see pawn, ECC pawn, ECC pawn. Oh, it reran. Okay. I really need to fix that. Okay, there we go. Third person character 2. That does work. Okay. Oh, okay, yeah, this is everything. So I guess it would be pawn, maybe? 4. Except for that floating thingy. That's fine. Alright, so we'll keep it as this. And then here we'd say if hit result. Because, like, wait, this doesn't seem to crash at least when nothing is in here, which is kind of weird. 1 second, let's just rebuild. Is it Control and F? There we go. This is what we actually wanted. Unreal Engine for C++, check F hit result. Okay, so that's a constant. Two-string reset. So what if we do this then? What would be if get actor returns an AA actor. An A actor, sorry. A actor actor equals result dot get actor. And then here we would just say the actor this. I think this might work. Nope. What does this return? This returns a bool. Okay. So this would be the if. here if hit, we'll say bool the hit actor equals boom, and then here we'd say if actor, maybe this. All right, and then this would be hit result dot get actor. I think this still failed, didn't it? Log macro. What's the problem here? Oh, right, because this needs to be a star, I think. Yeah, there we go. Hmm. Wait, this is two different things, right? Oh, interesting. So this seems to only be happening on the up. I thought I bound it to the pressed. Maybe it's something else, i.e. there's release, there's double. I just literally want pressed, so like right away. So I'm still, this has to be double pressed. That's so annoying. Why does it have to be double pressed? Maybe if I do IE release. And then UE log. UE. And then this is Alt P. So I guess the release seems to work the best. Oh, interesting. Okay. Weird. Okay, no, that seems to be working now. All right, so let's also do this. Here. Let's rename this to Cinder. And then add movement into game. We'll say archive. Scope server. Do procedural map. Pick a system for movement. Look into MMO. We'll archive that. We've already got one. Add the ability to move the camera. We already did that. Switching to jobs. Archive. Okay. So these things here, I'm just going to archive some of these. Scope. Out is. This needs to be renamed here. Edit. Scope. Server build. System. Wait. Networking stack. Here. Network stack. Out a procedural map. System for. Oops. System for procedural map. I'm just going to archive this one because I don't remember any details about it. There we go. Add another card. This one will make a task, and this will be select a character. Clicking on a character targets character, sets them as the target. And edit labels, task. What is another one here? Add scope system for character stats and stats. Scope system for character abilities. Edit label scope. Edit label scope. Boom. Okay. So today I want to work on this. If I get that done, then we'll start looking into these here. So first things first, let's target a character here. What I want to do is check the type of the thing I'm targeting here, and I want to make sure that it is targetable. So it means that we need to add a targetable kind of bool to everything that we want to be targetable. And in this case, we want all characters to be targetable. But we want to make it in such a way that it's going to be easy to make them all targetable. So working on that, here we go. Add create system to make any object system for to make any object null with toggle. Actually, I guess this would be a scope. Edit labels, scope. Edit labels, we do not want that. And then this would be scope. Unreal Engine 4. Add targetable flag to objects. E-flags. So wait, would this... architect object. This doesn't look like it's quite what I'm looking for. I think maybe there's something in that click that I had here, which is the ECC pawn, right? So if I look this up, there's going to be a long list of things in the collision channel here. And what we want to do is pick one of these, right? So like we have pawn, but we want something specific. Or maybe we want to add our own. Unreal Engine 4 channels. And then also Unreal Engine 4 multiple collision channels 1. Choosing what collides is obviously very important, but can be tricky, and it's a problem that we have spent quite a while discussing. While developing Unreal 4. In system, one sec. Choosing what collides. The system can see a little complex, seem a little complex at first, but is very powerful and consistent. So I want to give a little background on how we arrived at it. We'll talk about the different responses to collisions. Sorry. So we want to give a little background, how we arrived at it, talk at the different responses to collisions, how we use channels to filter collisions, and outline the difference between simple and complex collision geometry. Blocking, overlapping, and ignoring. The first thing to know is that when you say something should collide, you have to choose whether you can penetrate or not. A brick wall will block a player, but a trigger will overlap them, allowing them to press through. Both generate an event, hit, or overlap, respectively, in Unreal 4 terminology, but it is an important difference. Other objects may ignore the collision altogether, giving us 3 response types. Trace channels and object channels. The next big question is at the heart of collision filtering. The next big question at the heart of collision filtering is who gets to choose. In this object, is it the object that decides what type of query to collide with, or does the object declare what type of object it is looking for? In different scenarios, they both make sense, so Unreal Engine 4 supports both. Imagine we define 2 trace channels in our game, one for visibility and one for weapon queries. A brick wall is set up to block both. A shrub blocks visibility but not weapons, and bulletproof glass blocks weapons but not visibility. When you do this kind of query, you specify a single trace channel. Okay. Trace response, weapon ignore, visibility, block. Weapon block. Okay. If I changed this around, so the game code had to know what type of object to query for, or our game could need a huge number of different types to handle all of these situations. It also allows us to make spot fixes. In content later on, instead of changing the calling code itself and possibly breaking other things. That makes sense. There are, however, some situations where you do want to query the object based purely on their type. This is where we use object channels. One example is an explosion going off, and you want to quickly find all objects of type pawn or physics body within a certain radius. when you do this kind of query, you can specify multiple object channels. Unreal Engine 4 has a few built-in trace channels, visibility, camera, and object channels. World, static, dynamic, pawn, physics, body, vehicle, destructible. You can easily add your own edit project settings collisions through. They're limited to 32 in total. Okay, collisions between moving objects. Things get a bit more complicated when you want to handle collisions between moving objects because there can be so many combinations. In Unreal 4, each object is known to its... Oh, sorry. In Unreal Engine 4, each object knows its own object channel, plus a list of its responds, a list of how it responds to other object channels. When two objects intersect, we look at how they respond to each other and take the least blocking interaction, like so. Wait, what? So ignore is ignore, yeah. Wait, ignore. So imagine the following scene. I'm a little bit lost on this right now. Like, I think I get it. So, like, if it's ignore and if object A is ignore and object B, sorry, yeah. If object A is ignore, then everything's ignore. If object B is overlap, then everything will always be overlap. And if and then both of them have to block for it to block. That makes sense. So imagine the following scene. Pawn overlap. World static block. Block. Okay. Now the player moves forward. First, he will overlap with the shrub. The player is then of type pawn. And the shrub wants to overlap that. The shrub is of type world static, and the player wants to block that. Checking the chart, the final result is overlap. Similarly, the brick wall and player both want to block each other, so the player walks through the shrub, generating an overlap event, and is stopped by the wall, generating a hit event. This makes sense. If you had two players and wanted to become ghostly, he could change his response to the pawn channel from block to ignore, and then he could walk right through the player. Collision presets. Okay. Even though this system gives a lot of control over what objects in your level will collide with, in practice, most objects fall into common configurations to make things easier. Unreal Engine 4 has a collision preset system. Each preset contains an object type and a response to each trace and object channel in your game. When you select an object in the level, you will see a simple drop-down allowing you to select a preset. Okay, so if we come back to here, we select this. We have our, what was this in again? Was it the static mesh maybe? I think the static mesh is what we actually collide with, right? Collision, yes, default. Yeah, so it's the static mesh that we collide with. Here we go, collision. Collision is calling update overlap to initialize overlap state when loading in during level stream. If set to use config default, the default, blah, blah, blah. Yeah, okay. Character step up on. Wait, we can step on that? It says character step up on. Maybe we need to. This is interesting. Step up? Was it step up? In order to. Yeah, whatever. So we have that, can be damaged. That's spawning. Allow update newer. Always overlap state initialization. Default. I think we can only do like one thing, right? Block all, no collision. Ragdoll vehicle. Invisible wall dynamics. Interesting. Character mesh. Spectator. Maybe we should take a quick look at the actual one. This is in settings. Project settings. Yay. Collisions. So object channels. You can have up to 18 custom channels, including object and trace. So I think this would be a trace because we want to use it for specifically this, right? And I think this is using a trace. Salt at screen position, interesting. So this has like a bunch of code in it that, yeah, this is a trace, channel trace. Okay, so this is a trace. So what we want to do is we want to create our own custom trace. But collision presets, like, why collision presets, defaults, pawn. We look at pawn. Okay, and then we can select our custom one. All right, so we're gonna do that. We're gonna do custom, I think. Wait, was it always block all? Oh, I'll be right back. All right, sorry about that. I'm back. Welcome back, Jack. Good to see you again. Okay, so let's play this again. We're gonna walk over to this. We're gonna bump into it and jump up on it. It's blocking everything, but I wanna make it so this doesn't collide. This doesn't collide. Like none of this is selectable, but this and this are selectable. Now, I think that means that I need my own custom trace. Trace preset. I think it's a trace preset that I need. Wait. Okay. Ah. Okay, awesome. Okay, so this would be in here. Project settings. Collision. So this would be the trace. So we'd say new trace. We'd name it Targetable. Default response is going to be, I think block is probably what we want. Or no. Default will be ignore. And then, yeah, here we go. There, and then block all. Why didn't I see my collision here? Wait, do I need to go to custom then? I don't see mine. Trigger. I don't want to trigger. I want block all. Wait, what? Okay, maybe I did this wrong. Simple and complex collisions. One final thought to understand is that each object in Unreal Engine 4 can have both a complex and a simple collision representation. Complex collision refers to using the actual rendering geometry for collision. This is most useful for things like weapon traces, where you want to be able to shoot exactly what you see. You don't always want to collide with this though, and so each mesh can also have a simple collision representation consisting of a collection of spheres, boxes, capsules, and convex hulls. When you perform a collision query, you tell Unreal 4 what kind of geometry you want to collide with. Player movement, for example, collides against simple geometry to avoid getting stuck on little details. That makes sense. In the editor, there is a handy view mode that lets you see the world as a player will collide with it. Oh, that's kind of cool. Wait, where do you see this? What's the lit? And they're suggesting player collision? Okay, lit. Let's see here. Where's player collision? I don't see it. Player collision, there it is. Ah, yay. Interesting. That's not player collision. Can I walk right through this person? No, I still collide. I want to... Stupid. Lit. Okay. This is weird, though. Okay, collision filtering. Unreal Engine 4. Custom collisions. Physics. Okay, by default, there is no collision set on this mesh. Without collision, the player would be able to walk through the mesh. And if no mesh simulates physics, the mesh would simply fall through the world as soon as the play begins. You can test this by placing a mesh into the level before setting up collision and playing. Note that your player can walk right through the solid mesh. Also, if you wanted the door to blow away when you shoot it or start off in the sky and fall to the ground, you would need to set simulate physics to true. The details from the details panel, which you cannot do by default if a static mesh does not have collision. Sure. Add capsule. So wait, would I need to add a click capsule to everything, like an actual collision on a more complex map? Add. Let's see here. Simulating physics and collision presets. That's when selecting mesh actor in the edit. None of these are quite what I'm looking for here. Do I need to go back into that edit here? Let's see, project settings. Okay, and then we go to collisions. This one. So wait, why is this not working? See, I want this. I want all of this. When trace by channel, this information will be used for filtering. But all collisions, there's too much. Large number of properties broken into. World static. So collision and simulation generates hit events. Yeah, that's fine. Overlapping and ignore. Okay. Can we I want my custom stuff. Wait, what I need to do... Oh, maybe I need to do this. Wait a second. Pawn. Would it be... Oh, here we go. Targetable. It is there. Wait, am I blind? Is it actually in here by default? Targetable. Oh, there it is, right there. Oh, sweet. Edit. I was just like looking right past it. Collisions. Presets. Pawn. And this we want, we want to block. Accept. And then we do that. Now we want the targetable to be the one that we look for here. So how do we do this? ECC using Unreal Engine 4, using custom collisions in C++. Component collision tutorial. We'll assume that you're familiar with creating a project and adding C++ code. Components collision tutorial. Collision shape visually. Yes. Set collision profile name pawn. Okay. Project settings. Yeah, we're doing that. Pawn movement component. Coding behavior. This is not what I want because it's just doing the complete opposite of what I want. Look at that. Look at that. Beautiful. Just that collision right there. It's just, oh, it's hitting me hard there. It's like, hey, come do this. And it's just like, yeah, this is just goes to an empty page of, we don't do anything here. Still beautiful. So good. Component collisions. Maybe this one? Because, no, this is, again, the one that I just didn't want. Okay. Set collision profile name, fname. Or use a less intensive option and use one of the 18. Oh. Settings give you option to name them for blueprints and property lists. Here we go. Cool. I love it when they link to something that's not valid anymore. That totally doesn't actually help. Maybe this one. Oh, here we go. For C++, you can do this small macro hack in one of the main header files to make more natural naming. Here we go. So I'm going to I guess I'll just put this here. Again, here. Actually, no, I want to put this in the world. So I'll put that in, what is it, game, sender, oops, source, sender. Okay, so it's this one, I think. I think this one would probably be the one that we want here. More so than this. Yeah, I think this is what we want. So this would be targetable. Did I spell targetable wrong? Because you never know when I'm going to spell something horribly wrong, which is most days. It is a word. Targetable is a word, and they're just trolling me. They're trolling me for good fun here. There we go. Okay. Close that. And then in here, when we go down to here, we need to click the target target object. And then here we do etc targetable. Of course. Include generated. Maybe it would be game mode then. Okay, so this one makes it not work. Maybe here. I don't like it there though. Yeah, I didn't think that was gonna work. I think what we need to do is probably just put it in here. Here. Wow, it really doesn't like that. Why is this being so bad? EEC game trace channel. Cannot resolve game trace. Wait, what? Oops. Oh, ECC game trace channel. Okay, that's probably why. So maybe if I do this, because this was misspelled here. There, and then if we do this, then F9, will this work? It might work. Oh, it worked. There we go. So ECC targetable. It did work. Oh, that's beautiful. Okay, I'm doing that. It's amazing. Oops. Here we go. Okay, so play. Now, nothing. But if I click this pawn here, I should get something. I do, but if I click this, nothing. Sweet. Click that, nothing. Beautiful. Okay, so now what I want to do is I want to make this object here targetable. But I don't think this is going to be targetable because it doesn't have what I need. Yeah, it doesn't have anything attached to it. For collision. Oh no, it does have collision right here. No, it does not have collision. Okay, I'm just going to leave that because there's no point in having it. I will not put that there. But I got done exactly what I wanted. So now we can make anything targetable by attaching a targetable to it. Yes. Simple system. Okay, so scope. Now I can say that this scope is done. What we're going to do now is add targetable trace, add custom targetable tracer. And this will be a task. Okay, so now when we click a character, we want to make it targetable, right? So we want to have some defaults for this. We need to know what we're getting back, and I think everything counts as an actor, right? Unreal Engine is everything, and an actor is any object that can be placed into the level. Actors are a generic class that supports 3D transformations such as translation, rotation, scale. Yeah, okay. Beautiful. Okay, so what we're going to do is add the targetable system to this, right? Now this might need to be a little bit actually redeveloped here. Actually, I might not want to do it that the way, the way that I was going to do it initially. Because like the way I was going to do it initially was the same way that I was going to do it in what was it? It was Unity. which is like do these weird separate things that like we go and grab and stuff like that, and then we consolidate and whatnot. Where I think what I want to do here is I want to set them using there's this new system in that they've demoed in here, the action RPG stuff, and it's called, I think it's abilities. Yeah, gameplay ability system. And I want to use this, right? I think this can be used in order to make targeting and stuff like that a little bit easier. But I'm not 100% sure, mainly because I've not played with it yet. So that's what we're going to play with today, is the abilities system. So, yeah. Okay, so gameplay abilities, sometimes referred to as abilities, themselves are C++ or blueprint children of gameplay ability class. They define what the ability actually does in C++ code or blueprint scripting, as well as establishing elements of how the ability should be treated, such as replication and instancing behaviors. The logic within a gameplay ability will generally call a series of asynchronous binding blocks known as ability tasks. In the course of the logic that defines the ability, derived from the abstract uAbility task class. Ability tasks are written in C++ and frequently call one or several delegates in C++, or output execution pipes in blueprints. When they complete their work dependent on what the end result was, for example, an ability that requires a target might have an aim task with one delegate or output pin for confirming the target and another for canceling the ability. In action to gameplay ability, the gameplay ability system also supports gameplay attributes. And gameplay effects. Gameplay attributes are float values stored within the fGameplay attribute structure that influence the game or the actor in some way. These are typically values like health, strength, jump height, attack speed, and so on. Gameplay effects provide a way to alter gameplay attributes instantaneously or over time, commonly known as buffs and debuffs, such as subtracting magic points when casting a spell, generating and moving, granting a movement speed boost while a sprint ability is active, or gradually restoring health points over the lifetime of a dose of healing medicine. Any actor that interacts with the gameplay ability system must have the ability system component. This component will activate abilities, store attributes, update effects, and handle interactions between actors. Once you have enabled the gameplay ability system to create an actor that includes an ability system component, you can begin creating abilities and determine how actors should react to them. That seems easy enough. Because the gameplay ability system exists in a plugin, you will need to opt in to use it. I've already done that. To get a full range of capabilities of this system, add gameplay ability, gameplay tags, and gameplay tasks to the public dependency module names in your project's project name.buildcs file. This is easy to do by finding the list of public modules. Okay. Just go like that, and then we're going to come over to here, and we're going to say this is the project name build CS. So then we come over to explore, and then this, we can now close that, move this over like so. And we're just going to drop that sucker in like that. And I am going to break this down a little bit. I don't like how unlegible this is on my screen. It's too wide. There we go. Then we can Control F9. This will build it in. And we'll find out very quickly if it doesn't. It worked. Beautiful. Oh wow, I have a bunch of stuff here. Oh, BlizzCon's next week. I didn't know that. Wait, what? February 19th and 20th. So what's the thing for the... What do you get for buying the ticket here? Here, ticket buy, ticket buy. Helm of the Gear Store on February 19th. Huh. Interesting. So you can buy it. It's going to be way overpriced. Do you not need a ticket for this? Oh, here we go. Oh. It's a celebration collection. It's like this list of things that you get. Tracer. Here's the Storm Tracer. Some stuff. I think they said there was some stuff coming soon when I looked at this. It's really like this here might be decent. For golden loot boxes, who cares? 30 days of WoW time. This might be decent. Oh yeah, coming soon here. And coming soon. Do like that bear though. It's kind of nice. Anyways, moving on. The ability components is the main interface through which your game characters will access gameplay ability. The gameplay ability system. This component manages gameplay attributes, runs gameplay events, stores gameplay abilities, and even handles binding player input to gameplay ability activation, confirmation, and cancellation commands. Any actor that is intended to interact with the gameplay ability system should have an ability system component. So I would need to add this ability system component to the actor in question, which is, let's take, for example, this. So if I add component, it would be a gameplay task. Wait, what? No, ability system, right? And this would auto add this component, but I want to see if I can do it through C++ instead of doing it through this. I want to be able to do it through both, so. Ah, look at that code. I like to see that. A gameplay ability derived from the gameplay ability class defines what an in-game ability does. What, if anything, it costs to use, when or under what conditions it can be used, and so on. Because gameplay abilities are capable of existing as instanced objects running asynchronously, you can run specialized multi-stage tasks involving character animations, particle and sound effects, and even branching based on player input or character interaction that occurs during execution. That's kind of interesting. Gameplay abilities can replicate themselves across the network, run on client or server machines, including client-side prediction support. Yes! We do need that. Client-side prediction is very important. It makes your game feel right. Client-side prediction, very important. So what it does is when I press a button, I need to be able to state that, hey, this happened. So what we'll do is, so what it is essentially is, the server is a source of truth and dictates what actually is happening in the world. And the client is essentially a dumb client. But if you have a fully dumb client or a thin client, depending on terminology you want to use, or like, yeah, thin client or dumb client, right? What you have is essentially everything has to make a round trip to the server in order for anything on the client to happen. So if you want to move forward, the server has to tell the client, which is the game running on your computer, that the character is moving forward. So I press W, right? That sends the information to the server. The server says, hey, you're moving forward to this place, right? And a true super dumb client would just like teleport you there instantly, right? But obviously that doesn't feel right. You can actually see dumb client in action if we do sudo kid.dev, right? What happens here is when I move, right? Oh wow, I think the game's busted. Might need to be restarted. None of the enemies are moving. Makes it really easy though. Anyways, so when I click here, there's a round trip from here to the server and back before the character actually moves. It just happens so quickly that you don't even notice it, right? And that's it. And then like it actually makes a round trip every time the character moves one square, right? And this is a dumb client, but it makes it hard to move the character smoothly. That's why you jump square to square rather than your character glide with the walking animation at a reasonable rate. So dumb client versus smart client. A smart client would do client-side prediction, right? So client-side prediction allows you to say, hey, we're just going to start this action. You've pressed the button, we're going to start. If the server comes back and tells us that, no, this is invalid, we're going to roll that action back and put ourselves in line with what the server states, right? So if I'm like, if the client says that I am, say, at XY coordinates, and the server tells the client that no, you're off by 10 pixels to the right and 100 pixels to 100 pixels to the, or we'll use a map, right? You're 10, say 10 squares too far to the right, and you're 100 squares too far to the north. What the client will then do is try and it will roll you back and pull you back to where the server states you are, right? And that way, when you move forward, your character starts moving right away. If you're on a bad connection, you don't have to wait for the server to respond back, right? So that's client-side prediction. Anyways, I probably didn't do a very good job of explaining it. And I'm out of water. I'll be right back. I'm going to go grab some water. All right, I'm back now. All right. And all right, so and even sync variables and make remote procedure calls. And then remote procedure calls are just like I'm telling the server to execute a specific line of code, essentially. Gameplay abilities also provide flexibility in terms of how the engine implements them during game sessions, such as extensible functionality to implement cooldowns and usage costs, player input, animation with enemy montages, and reacting to the ability itself being granted to an actor. Excuse me. Granting and revoking abilities. Before an actor can use an ability, its ability system component must be granted that ability. The following ability system component functions can grant access to an ability. Give ability specifies the ability to add with an F gameplay ability spec. And returns an F gameplay ability spec handle. Give ability and active once specifies the ability to add an F gameplay ability spec and return an F gameplay ability spec handle. The ability must be instanced and able to run on the server. After attempting to run the ability on the server, an F gameplay ability spec handler will be returned. If the ability did not meet the required criteria, or if it could not execute, the return value will be invalid and the ability system component will not be granted the ability. It's kind of interesting. So that's specifically for give and activate once. Okay. All right, that makes sense. The following functions can revoke access to an ability from an ability system component using fGameplay ability spec handler that was returned when the ability was granted. Clear ability removes the specified ability from the ability system component. Set remove ability on end removes the specified ability from the ability component when the ability is finished executing. So these are like short run tasks, right? So like it's essentially a function I run, and you can set things to do at the end of and on specific actions that are taken within it, right? Or on it, sorry. So like I've got this, essentially you can kind of think of it as like a process, right? That's executing in memory, like on the system. And that's actually probably what it is. It's just like a multi-threaded process that's running. Or probably a multi-threaded process that's running. Anyways, so that happens, right? So like we trigger it, and say we're halfway through it. We can say, hey, this is no longer valid anymore. Please clear it. And then it would clear. And then it would stop execution at that point, or at some set checkpoint within there, right? Say it was in the middle of like targeting somebody or playing an animation, right? You might finish playing the animation and then clear all future aspects of it, or it might stop midway through the animation depending on like what its clear conditions were, which we haven't gotten to yet, so I can't speak to. Then remove the ability on end, exactly what that is, right? Like it triggers a function to run essentially that removes it from the character as soon as it finishes execution. So that's kind of neat. Clear all abilities, removes all the abilities from the ability system component. That'd be good for, that might be decent for something like, so like this one here would be remove ability on end. This would be something like maybe a debuff, right? Or a buff where you'd remove it after a thing finished executing, and then that would use the remove ability on end because it would finish execution after a certain amount of time, and then it would clear itself. Clear ability would be maybe something that you would use if, say, like if you've ever played World of Warcraft and you start casting a fireball. Actually, we can just, I've got this open. We can actually go into WoW Classic, and I think there's a character. I can just pop open a character and show you what I mean. So maybe like clearing a debuff or something like that. Here, mage is perfect for this example, right? So I'm in L1 Forest. Walk out of L1 Forest as my gnome parts. Let's see. Oof, I really like that. Oh, that's beautiful. Anyways, so then I can click here. I can click this and hit escape, and it stops. So that'd be the clear. Frost armor is currently active. I could clear this by right-clicking on it. Then I would put this back on, right? And then this 30-minute timer right here would be my clear. What would it be? It would be the clear on end or whatever. So what was it? Set remove ability on end, right? Like maybe I would remove that because that'd be a buff or a debuff. And then say the clear all abilities. Maybe I've become completely stunned, and we just want to quickly disable all of the abilities that I have access to, so my character can't do anything. At that point, maybe we will just attach the clear all abilities And that would do that. Okay. A gameplay ability's basic execution lifestyle after being granted to an actor's ability system component looks like this. Can activate ability. Lets the caller know whether or not the ability is available for execution without attempting to execute it. For example, your user interface may need to gray out and deactivate icons that the player can't use, or play a sound or a particular effect on that on the character to show that a certain ability is available. Call active ability. Execute the game code associated with the ability, but does not check to see if the ability should be available. This function is usually called in cases where some logic is needed between can activate ability check and the execution of the ability. Interesting. The main code that users need to override with their abilities custom function. The main code that users need to override with their ability custom functionality is either the C++ function called activate ability or the blueprint event called activate ability. Okay. Gameplay abilities do not carry out their primary work in a tick. That's kind of interesting. It also makes sense because it says it was asynchronous, and the tick is every frame. Functions like actors and components do. Instead, they launch ability tasks during activation, which do most of the work asynchronously, and then handle the output of those tasks by hooking into delegates in C++ or connecting nodes to output execution pins in blueprints. The commit ability function is called from within active when will apply. The commit ability function is called from within active, will apply the cost of executing the ability, such as subtracting resource from the gameplay attribute, such as magic points, stamina, or whatever fits your game system, or applying cooldowns. Okay. Cancelability provides a mechanism to cancel the ability, although the abilities can be canceled function can reject the request, unlike commit ability. This function is available for callers outside of the ability itself. Because that actually does make a lot of sense, right? Because you want to be able to call it from, say I have dispel, right? So I want to dispel something off of a player, like remove a buff, right? I need to be able to cancel that ability, which would give me that dispel functionality that I was looking for. This function is available for side of the ability itself. A successful cancellation will broadcast to on gameplay ability cancel before going through the standard code path for ending the ability, given the ability a chance to run special cleanup code or otherwise behave differently when canceled than it would if it had ended on its own terms. So let's say you're running or you're casting, you hit escape in this case. All right, so you're casting your frostbolt, you hit escape. You can have it execute a certain little thing right? That maybe plays the animation of you putting your hands down. And then it removes the bar and stuff like that. It does all the tear down for whatever this is. Try active ability is the typical way to execute abilities. This function calls can activate ability to determine whether or not the ability can run immediately, followed by call active ability if it can. That makes sense. End ability. In C++, or the end ability node in Blueprint shuts the ability down when it is finished executing. If the ability was canceled, uGameplay ability calls uGameplay ability class will handle this automatically as part of the cancellation press. But in all other cases, the developer must call the C++ function or add the node into the abilities blueprint graph. Failing to end the ability properly will result in the gameplay ability system believing that the ability is still running and can even have effects such as preventing future use of the ability or any ability that it blocks. For example, if your game has a drink health potion gameplay ability that doesn't end properly, the character using that ability will be unable to take any action that drinking a health potion would prevent, such as drinking another potion, sprinting, climbing ladders, and so on. These make sense. The ability blockage will continue indefinitely since the gameplay ability system will think that the character is still busy drinking the potion. Interesting. Gameplay tags can help determine how gameplay abilities interact with each other. Each ability possesses a set of tags that identify and categorize it in ways that can affect its behavior, as well as gameplay tag containers. As well as gameplay tag containers and gameplay tag queries to support these interactions with other abilities. Gameplay tag variables. Interesting. Cancels any already executing ability with tags matching the list provided while this ability is executing. Block attribute abilities with tag. Oh, that's interesting. Okay, so in this case, if you were to get stunned, you wouldn't clear all or remove all. You would just block all. Prevents execution of any ability with the matching tag while this ability is executing. That's really cool. Activation own tags. While this ability is executing, the owner of the ability will be granted this set of tags. Interesting. Activation required tags. The ability can only be activated if the activating actor or component has all of these tags. Activation blocked tag. The ability can only be activated if the activating actor or component does not have any of these tags. Target required tags. The ability can only be activated if the targeted actor or component has all of these tags. Target blocked tags. The ability can only be activated if the target actor or component does not have any of these tags. Beautiful. Gameplay ability support replication of internal state and gameplay events, or turn replication off and save network bandwidth. Gameplay abilities support replication of internal state and gameplay events, or to turn replication off and save network bandwidth and CPU cycles. The ability's gameplay attribute replication policy can be set to yes or no, which we will always leave as yes, unless it's something that's client side only. Then you would want to set it to no, because you don't want to replicate it, right? So would be an example of something that would be client side only. Somebody hits escape, right? And that brings up a menu maybe. Because I think they use this for things like menus sometimes. It's the only thing I can think of. We could go crazy with all of these and it would be insane, but I don't think that I want to. This option. Okay, so okay, and this will control whether the ability replicates instances of itself, makes state updates, or sends gameplay events across the network. For multiplayer games with abilities that do replicate, there are a few options for how replication is handled, known as gameplay net execution policy. Local predict. This option provides a good balance of responsiveness and accuracy. The ability will run on the local client immediately upon the client issuing the command, but the server will have the final word and can override the client in terms of what the ability actually what the ability's actual impact was. The client is effectively asking permission from the server to execute the ability, but also proceeding locally as if the server is expected to agree with the client's view of the outcome. Because the client is locally predicting the behavior of the ability, it will freely predict smooth and lag free as long as the server does not contradict the client's prediction. So in this situation, right, we might want to do something like start the execution of the frostbolt, right, and assume that the server is going to agree with us. But then maybe we might want to essentially block or wait until we receive information back with how much damage it's going to do or something like that before we actually say display numbers to the user or impact the other character on their screen or something, right? Like there's a bunch of different ways that we can do this. The client is effectively asking permission to do lag free. Local only. The client simply runs the ability locally. There's no replication to the server, although the ability will run on the server if the client is using it as a if the client using it is the host playing on a physical server machine, or if it is a single player game. This does not apply to dedicated dedicated server games, as there is never a client playing on the server machine. Anything the client affects will, with this ability, will still flow. Wait. This does not apply to dedicated server games, as there is never a client playing on the server machine. Anything the client affects with this ability will still follow normal replication protocols, including potentially receiving corrections from the server. Interesting. Server initiated. Abilities that initiate on the server will propagate to clients. These are often more accurate from the client perspective to what is actually happening on the server, but the client is using the ability will observe a delay due to lack of local prediction. While this delay should be very short, some types of abilities, especially rapidly performed actions in pressured situations, will not feel as smooth as they would in local predict mode. Understandable. Server-only abilities. Abilities will run on the server or will not replicate to the clients. Any variables these abilities change will replicate as any variables these abilities change will replicate as they normally do, meaning that the ability can affect server authoritative data, which will then propagate to the clients in this way. The ability can still have effects that clients observe, even though the ability itself will only run on the server. Understandable. When a gameplay ability executes, a new object of the ability type will usually spawn to track the ability in progress. Since abilities can execute very frequently, in some cases, such as battles between 100 or more players and AI characters in Battle Royale, MOBA, MMO, or RTS games. There may be cases where rapid creation of ability objects can negatively impact performance. To address this, abilities have a choice of 3 different initiation policies, offering trade-offs between efficiency and functionality. The 3 supported instancing types supported are, wow, that's poorly worded. Really poorly worded. All right, instance per execution. Obviously, every single time somebody presses it, it creates a new instance. Yeah. A copy of the ability object will spawn each time the ability runs. There are advantages and disadvantages to this. Say I want to I don't have a good example of this right this moment, but yeah, it's general idea, right? Anyways, they're going to give us an example anyways. Copy of the object will be spawned each time the ability runs. The advantage to this is that you can use blueprint graphs and member variables freely. And everything will be initialized to default values at the beginning of the execution. While this is the simplest instancing policy to implement, it is ideal for abilities that run infrequently due to large overhead involved. Yeah, it's very, very true. For example, an ultimate in a MOBA would be a reasonable use case, as there tends to be a long cooldown, usually 60 to 90 seconds between execution, and there are only a few characters, usually between about 10, who can use these abilities at all. Basic attack ability used by the computer-controlled minions would be a poor candidate, as there may be hundreds of them at a time, and each can issue basic attacks fairly frequently, causing rapid creation and possible replication of new objects. Definitely don't want that. Each actor will spawn one instance of this ability. So this is instance per actor, which is, I think, fairly self-explanatory. Each actor will be granted one instance of this particular ability, and they can execute it as many times as they want, but they will only ever have one instance of it. Each actor will spawn one instance of the ability when the ability is first executed. The future executions will reuse it. Yeah, this creates the requirement to clean up member variables between execution of the ability, but also makes it possible to save information across multiple executions. Per actor is ideal for replication, as the ability has a replicated object that can handle variable changes and RPCs, but does not waste network bandwidth and CPU time spawning new objects every time it runs. In large-scale situations, this policy performs well, since large numbers of actors using the ability, for example, in a big battle, will only spawn objects on their first ability use. Sorry. This is the most efficient instancing policy in all categories. The ability will not spawn any objects when it runs, and will instead use class default object. However, this efficiency introduces several restrictions. First, the policy uniquely requires that the ability is written entirely in C++, as blueprint graphs require an object instance, which I'm also fine doing. You can create blueprint classes. You can create classes of non-instanced ability, but only to change the default value of exposed properties. Further, the ability must not change member variables or bind delegates during its execution of the ability. The ability also cannot replicate variables or handle RPCs. Oh, interesting. So it's local only. This should be used only for abilities that require no internal variable storage, although setting attributes on the user of the ability is possible, and do not need to replicate any data. It is especially well suited for abilities that run frequently and are used by many characters, such as basic attacks by units in a large-scale RTS or MOBA title. Oh, interesting. Okay, so we might be able to get away with using that quite often instead of the per actor. Today's just like the reading of everything. We want to get targeting systems down, so what are we doing? reading about the ability system because it seemed I remember looking into this a little bit, and it seemed to work. Seemed to be kind of what I was looking for. So yeah. Okay, gameplay events. Triggering with gameplay events. Gameplay events are data structures that can be passed around to trigger gameplay abilities directly, sending a data payload for context without going through the normal channels. The usual way to do this is by calling send gameplay event to actor and providing an actor that implements the iAbility system interface. Wait, what? Usual way to do this is by calling send gameplay event to actor and providing, okay. That makes sense, yeah. And the contextual information and gameplay events require contextual information that gameplay events require. But it is also possible to call handle gameplay event directly on the ability system component. Because this isn't the normal path to calling gameplay abilities, context information that the ability may need will be passed through the F gameplay event data structure. This structure is generic and will not be extended for any specific gameplay event or ability, but should be sufficient for any use case. Polymorphic context handle field will provide support for additional information as needed. That makes sense. When a gameplay ability is triggered by a game event, it will not run through the active ability code path, but will instead use the ability from event, which provides the additional context data as a parameter. Be sure to handle this code path if you want the ability to respond to gameplay events. But also be aware that once implemented in your gameplay ability blueprint, active ability from event will replace active ability, taking all activation traffic through itself. It's a good thing to know. So much stuff to go over. I think 2 hours of reading is a bit enough for today. I will let you all go. Thank you all for joining. I will pick up tomorrow, probably do some more reading before bed so we don't have to go through all of this tomorrow and we can kind of jump right in and hopefully start doing stuff tomorrow. All right, I will see you tomorrow, and thank you everybody who joined and whatnot, and we'll pick it back up. All right, bye-bye for now.